Good morning, students. So we discussed about in the last class. So what is the topic? So what is the friction and so types of the friction? What is the advantages and disadvantages of the friction? And so decreasing of the friction by using the four methods: lubricants, ball bearings, streamlining, okay, and polishing, etc. We discussed in the last class. Also, we discussed in a law of rolling friction. And so today discuss the another topic. So that topic is so expression for, okay. So the expression for acceleration of a body down a rough inclining plane. Okay. So expression for the acceleration of a body, to find out the acceleration of a body and rough inclining plane. Okay. So now here taken that is a rough inclining plane. So this is called as a rough inclining plane. So making angle theta with the plane, and we have taken the object. So this is called as the object, and so here the net weight is acting downwards mg. So weight of the object, and so here and we have taken, so this is called as a mass of the object is m, and so normal reaction n and mg. Okay. So mg is taken, fk kinetic friction. So we have taken mg sin theta cos theta. Okay. So now we consider the plane. So that is body of mass m on inclining plane. Let us consider a body of mass m on inclining plane. Okay, got it. So now here see that in diagram. So that is called as a m is the mass of the body on a inclining plane. So making angle theta with the horizontal. Okay, got it. With the horizontal. And so the some forces are acting on a body. So that is the weight of the body is acting vertically downwards. Okay. So the n is the normal reaction acting in a upward. Okay. So the normal reaction, n is means the normal reaction acting upward direction. Okay. So here that is called as a weight of the object. Okay. So weight of the body can be classified or divided into rectangular components. So that is called as a mg cos theta. So one is taken, another is mg sin theta. So F is called as the kinetic friction. Okay. So the kinetic friction or dynamic friction. Okay. So the dynamic friction. So up down, that is means inclined plane, up of the plane. Okay. So మనకు పైకి పనిచేస్తుంది. Okay, up down, up direction. అంటే so plane upward direction లో పనిచేస్తుంది. So that is called as a Fk kinetic friction. Okay, so weight of the object is acting vertically downwards, and so mg sin theta, mg cos theta are that is the components. Okay, horizontal and vertical components, and n is the normal reaction. Here taken n is the normal reaction acting upward direction, acting that is the perpendicular to the body. Okay, perpendicular to the body. This is called as a perpendicular to the body, and Fk is acting upward. Okay, up of the plane. So Fk kinetic friction, that means. Okay, so now consider the body, that is the body of the mass here. Okay, so and is placed on a inclining plane. Okay, got it. So the force is acting, that is called as a we have taken, that is called as a Fk is equal to mg sin theta. Fk is equal to mg sin theta. Okay, got it. Fk is equal to mg sin theta. Now here, so that is called as Fk is equal to mg sin theta. So the two forces are the two forces are equal, and also n is equal mg cos theta. N is equal mg cos theta. Okay, got it. So that is means here that the total net force is acting on the body. So that net force is acting on the body. So mg sin theta minus fk. Okay. So the net force is acting on the body. So that is called as a mg cos theta or mg sin theta minus fk. So mu k is equal to fk by n. Fk by n. So Fk is equal mu k into n. Got it? So mu k is nothing but, so the coefficient of kinetic friction. Coefficient of kinetic friction. So mu k is equal to Fk by n. N is the normal reaction. Okay, got it? So that is from equation Fk is equal mu k into n. Now substituting the equation we get, so F is equal mg sin theta minus fk. Fk is equal to mu k into n. So mg sin theta minus mu k into n. So mu k n. N is equal mg cos theta. Mg cos theta. So from this equation, so mg is taken common. So sin theta minus mu k cos theta. Okay. So this is called as a net force is acting on the body. F is equal to mg sin theta minus mu k cos theta. But according to Newton's second law, F is equal to ma. Okay. So now here F is equal to ma. So ma is equal to mg. Okay. So sin theta minus mu k cos theta. So m are cancelled. Acceleration A is equal to g sin theta minus mu k cos theta. Okay. So this is called as acceleration. Okay. Acceleration of a body down on a rough inclined plane. So A is equal to g into sin theta minus mu k cos theta. Okay, got it. So here that is the resultant force F is equal, so mg sin theta minus fk. Okay, so fk we can write, so mu k is writing as things, that is called as the mu k is called as a coefficient. Okay, so the coefficient of kinetic friction, so mu k is equal to fk by n, fk is equal mu k into n. Now substituting and n is equal, so that n is nothing but normal reaction is equal to mg cos theta. So we can write n is equal to mg cos theta and substituting, okay, taken the common. But according to Newton's second law, F is equal to ma, so ma substituting, so ma are cancelled, that we get the acceleration on a rough inclined plane. Okay, got it. So now next we discuss about the topic is Newton's second law. And F is equal to ma through that. Okay, so Newton's second law. According to Newton's second law, okay, statement we can write. F is the directly proportional dp by dt. That means so the rate of change of the momentum. Okay, so the rate of change of momentum is directly proportional to resultant force acting on a body. Okay, along applied force. Okay, so the force acting on body. Okay, so is taken. That is called as a, write in a mathematical form, F is directly proportional dp by dt. Okay, so what is F is dp. dpp is nothing but momentum. So the momentum, that means, so the rate of change of the momentum, the rate of change, rate is means time. So the rate of change of the momentum is directly proportional to the net force or resultant force is acting on the system, acting on the body, is called as a Newton's second law. Okay, according to definition of the Newton's second law, the rate of change of the momentum is directly proportional to the resultant forces acting on a body. So the F is directly proportional dp by dt, we can write. Now we can prove that. So our expression for F is equal to ma. Okay, so F is equal to directly proportional dp by dt according to Newton's second law. So F is directly proportional dp by dt. But P is equal, already we know that, so mass into, so velocity is called as a momentum. Mass into velocity is called as a momentum. Now substituting in this equation, so we get F is directly proportional, so d into mv by dt. Okay, so F is directly proportional, m is the taken common, that is called as the mass of the body. Okay, so first of all we consider the mass of the body is m is taken, so I am moving with velocity is v after time interval dt. Okay, so in a uniform acceleration, so that is called as a, m is the, consider the mass of the body, and so we can write the dv by dt. Okay, so differentiating with respect to time, velocity. So the dv by dt is called as a acceleration. Is called as a acceleration. A. That means the rate of change of the velocity. The rate of change of velocity is called acceleration. Acceleration A is equal to dv by dt, and substituting in the equation. So V F is directly proportional m into A. Okay, m into A. dv by dt is equal A. So F is equal, F is the whole proportional can be neglected. Some constant are taken, that is equal as a k into m A. If case of k is equal to 1, k is equal to 1, we can write F is equal to ma. And units are measured. Okay, SI units is measured. So that is the force. Forces are found in newtons. Okay, so 1 Newton is defined as, what is the Newton? SI units are the force find out at newtons. Okay, so what is the newtons is defined as, so the acceleration of the body is, okay, 1 meter per second, and the mass of the body is taken 1 kg. That force is acting on the body is called as a 1 Newton. Okay, so the 1 Newton is equal to, so the acceleration 1 meter per second, and so the mass of the body we consider the, that is called as a 1 kg. Okay, so the force is acting on the body is called as a 1 Newton, and CJ's units are measured dyne system. CJ's units dyne system. Okay, so dynes are measured. This is called as a Newton second law, and so the expression for F is equal to ma. Okay, so the rate of change of the momentum is directly proportional to the net force is acting on a body is called as a, okay, Newton's second law. So now consider the body of a massium with velocity is v and acceleration a. Okay, so the time is taken, time interval is taken dt. So now here the F is directly proportional dp by dt. So P is equal mass into velocity. Now substituting, so mass is a constant, that is called as a mass of the body is 10 kg, 5 kg are the taken. But dv by dt is right side. So dv by dt is nothing but acceleration. So that the acceleration substituting, so we get F is equal to ma. That is measure in SI units. Okay, so SI units, so taken newtons, so and CJ's units dyne. Okay, got it. Right. So next one topic. So what is the angle of friction and what is the angle of repose? Okay, so angle of friction, it is denoted by the phi. Angle of friction. Okay, angle of friction. So what is the angle of friction and so what is the angle of repose? Angle of friction, it is denoted by the phi. So first of all we taken the object is placed on surface. So this is called as the mass of the object is m, and normal reaction is m, and mg is acting vertically downwards. Okay, got it. So this is called as a, now here this is the force is F is acting. Okay, the F L is taken. Normal reaction is along. Okay, and so the resultant normal reaction is acting. Okay, so the resultant normal reaction. Okay, so we have taken O and OA and OB and OC. Okay, is taken. So this is called as or is called as a resultant. Okay, so the angle of friction. So the angle of friction is called as a, this is called as a pi, angle of friction. So normal reaction N is taken. Okay, so Fl is called as a limiting friction is taken. Okay, got it. So now here consider the body of a mass m is placed on surface of the earth. Okay, got it. And so that is means what is the angle of friction? So the body here taken N is called as a normal reaction. F is called as a limiting friction. Okay, so now R is called as a resultant. Okay, this resultant is made of normal reaction and Fl. So in this called as the weight of the object is acting vertically downwards. Okay, so now here consider what is the angle of friction, how to define the angle of friction. So angle of friction is means pi. Okay, so the angle of friction is defined as, so the resultant. Okay, so the resultant to the normal reaction with limiting friction. Okay, normal reaction with limiting friction to the normal force. Normal, that is called as the resultant friction or resultant force. So the resultant friction is called as a angle of friction. Angle of friction. So what is the angle of friction? Angle of friction is defined as the resultant. Okay, so the resultant friction to the normal reaction with the limiting friction. Normal reaction with the limiting friction is called as a angle of friction. Okay, so from the diagram, so that is called as the angle of friction is taken. Okay, so tan alpha is equal, so this is called angle. So opposite side by, okay, adjacent side. So that is means CB by we can write OB. Okay, so CB. So CB is equal to OA we can write. OA by OB is equal, right? That is also we can write that OB. Okay, so the tan alpha is equal to OA. So OA means FL by limiting friction by. So OB is equal as a N. Okay, that is nothing but tan alpha is equal FL by N. Okay, so this is called as a equation 1, or alpha is equal. Okay, so that is called as a tan inverse. So FL by N is taken. Equation 1. Okay, got it. So that is called as a FL by N. FL by N we can write FL by N is equal to mu K, that is a mu K kinetic friction. We can write kinetic friction. So mu K we can write. That is called as a alpha is equal tan inverse mu K we can write. Okay. So tan alpha is equal to mu K. That is not as the equation 1. So that is called as a tan alpha is equal to mu K. So this is called as a equation 1. Okay, got it. So what is the angle of friction? So the angle of friction is defined as or made of, so the resultant friction to the normal reaction with the limiting friction is called as the angle of friction. So the angle of friction alpha R is taken is the pi is taken. So this is called as a pi. So pi is equal. Okay. So now here also pi. So pi is equal to tan inverse mu K. Okay, so mu K is nothing but, so the coefficient of kinetic friction or dynamic friction is also we can write. And so now discuss the next one. Angle of friction is completed. What is the angle of repose? angle of repose. Angle of repose. Okay, angle of repose, it is denoted by the here pi, here alpha. Alpha is taken. Angle of repose. So what is the angle of repose? So this is called as a inclining plane. Okay, so the inclination. So inclination angle theta with the horizontal. Okay, horizontal. So what is the angle of repose? So angle of repose means so that is means so the angle is made, that is the theta here taken is called as the alpha. The theta is equal alpha. So here making, that is the inclination. Okay, so the plane of inclination with the horizontal is called as the angle of repose. Okay, that means ఇక్కడ మనం ఇంక్లినేషన్ థీటాని ఇంక్రీజ్ చేసుకున్నట్లయితే ఏదో ఒక సందర్భంలో అనేది ఆబ్జెక్ట్ జారుతుంది. ఓకేనా, ఆబ్జెక్ట్ కిందికి వస్తుంది. అంటే కిందికి రాకముందు ఎప్పటి వరకు అయితే ఆ ఫోర్స్ పనిచేస్తుందో దట్ ఈస్ కాల్డ్ as యాంగిల్ ఆఫ్ రిపోజ్. యాంగిల్ ఆఫ్ రిపోజ్. So the angle of repose. So what is the angle of repose? Angle of inclination of a plane. Angle of inclination of a plane. Angle of inclination of a plane. Angle of inclination of a plane with the horizontal. With the horizontal is called as a angle of repose. That is called as a alpha. So that means which is tends to move to or ready to on a inclining plane. Got it? So what is the angle of repose? Angle of repose means so angle of repose is defined as angle of inclination of a plane with the horizontal. Angle of inclination. This means angle of inclination is called as the theta. With the horizontal is called as angle of repose, which is the body is tends to move on a surface or on a inclining plane, on a inclination plane. Got it? So tends to move or ready to move. Okay, got it? Now, so the angle of repose is equal to the angle of friction. Okay, so on a inclining plane, on a taken rough inclining plane. So now consider the rough inclining plane. So this is called as a rough inclining plane. Here taken the object. So object is taken mass m. Mass m. So the normal reaction is acting in a upward direction. Normal reaction. And is acting, so that is called as a mg cos theta is taken. And so weight of the object mg. And this is called as a mg sin theta. Okay, component. Here taken, so that is called as a fk, kinetic friction. So here taken, that is called the theta. So theta is equal, we can write after some time. Okay, so now we consider the body of a mass m on a inclining plane. Okay, so consider the body of a mass m on an inclining plane. Now here taken, so the forces is acting on the body. So this is called as normal reaction, and n and fk is called as a kinetic friction is acting on a plane of up and so here mg is nothing but weight of the object. So that is acting vertically downwards, and so the weight of the object classified in a two components, that is called as a mg cos theta, and here taken mg sin theta. So the theta is called as a angle of inclination to with horizontal. Okay, got it? So now here taken the forces are equal. So mg sin theta, okay, mg sin theta is equal to fk, and equation 1 we can write. So now another taken is known as a normal reaction. N is equal to mg cos theta. Okay, these two equations are divided, equation 2 by equation 1, or equation 1 by equation 2. Okay, so from equation 1 and 2, from equation 1 and 2, so we get so fk by n is equal to mg sin theta by mg cos theta. Okay, mg are cancelled. So sin theta by cos theta is equal tan theta. We can write that is called as tan theta. And fk by n is nothing but, so mu is equal to f by n. Okay, so now here taken fk, so here taken mu k, tan theta is equal mu k. Okay, So if in this condition, okay, so the tan theta, so the theta is equal to tan inverse mu k. But here one condition is taken, that is called as A. Here the body is moved to, tends to, ready to slide down. Okay, that particular condition, that theta is called as a alpha, we can write. Theta is called as a alpha. That means so the mu k we can write so tan alpha. Okay, so this is called as a equation 3. Okay, so the body is on an inclining plane. Okay, inclining plane, and the body is just moved to or ready to slide down on a inclining plane. So the theta is equal, we can write alpha. Alpha is called as a angle of repose. Angle of repose. Now here substituting in the equation, theta is equal to alpha. So mu k is equal to tan alpha. Okay, so but before equation, what is the angle of friction? So the angle of friction is equal as a mu k is equal to tan pi, we can write. So this is called as a equation 4. Comparing of these two equations is equal. So tan alpha is equal to tan pi, that is equal to alpha is equal to pi. So these two equations are, or these two angles are equal on a inclining plane. Got it? So this is called as a very important topic. So what is the angle of friction? What is the angle of repose? So when these two conditions are equal on a inclining plane, so that is that alpha is equal to pi. Got it? So a black body of a 4 kg mass is a resisting on a rough horizontal plane, and he is about to move when the horizontal force F 30 newtons is applied on it. G is equal. So find the total contact force are exerted by the plane on the black. Okay. So now we consider the, so that is called as a applied force is equal. Applied force is equal. The frictional force is equal. Frictional force is equal to applied force. Applied force. Okay. So the applied force, so that is equal under root of F K square by normal reaction square. Okay. So because we have taken already, we discussed in the last class. That is called, for example, we have taken so rough horizontal plane. So this is called as a rough horizontal plane. So the black body is taken. So that is called as the mass M is equal to 4 kg. 4 kg. the normal reaction is acting N. So the G is equal is taken 10 meter per second square. So here taken the force F is equal. Okay. So the force F is equal given 13 newtons. So here the resultant. So the resultant is taken. So the resultant here given this force resultant means so Fk and N. Fk square N. Okay, so the resultant that is R is equal under root of Fk square plus N square. So what is the N? N is equal as normal reaction. So normal reaction is equal to weight of the object. That is called as mg. So m into g, n is equal to m. M is the mass. So mass is given 4 into 10. That is equal to 40 newtons. So Fk. The frictional force. The frictional force is equal already applied force. That is the frictional force is equal applied force. That is equal to applied force on the body is taken 30 newtons. So 30 newton square plus something that is the normal reaction is equal to 40 square under root. So 30 square is equal to 900 plus 40 is equal to 600 under root is equal to 2500 is equal to, okay. So 2500 is equal to 50. So the 2500. So 16 plus 5. So that is means 50. So 50 into 50. 50 into 50. So 5 is 25. Got it? So the 50 resultant force is equal to 15 newtons. Okay, got it? So here consider the 4 kg of on a rough horizontal plane. So this is called as the rough horizontal plane. The mass of the body is F is equal to 4 kg. And so G is equal to 10 meter per second. And F is equal to 30 newtons is acting on your body. And Fk is equal. So the Fk and newtons is equal. This is called as the resultant force. So the resultant force R is equal. R is equal to root of Fk square and normal reaction square. Normal reaction is equal weight of the body. Here weight of the body is given, so mass m into G. So substituting 40 and that value substitute in the equation. So we get 50 newtons. Okay, got it. Right. Thank you, students. Now we discuss about the another chapter next class. Okay, thank you.